So today we're going to talk about using congruent triangles. Now, how are we going to use congruent triangles? We'll read this part and you understand what we mean by using congruent triangles. Okay, anybody want to read our goal? Go ahead, Brianna.
Our goal is the preceding section was to prove that two triangles are congruent. Our goal in this section is to deduce information about segments or angles when we have shown that they are corresponding parts of congruent triangles.
Okay, so as you did your homework last night, you know that they wanted to show that the two triangles are congruent, right? Now tonight's homework is going to be, after that, we're going to go one more step from it. Okay? So take a look at this example. Okay, what we mean by that is this. You have this picture, you don't have to draw this. Okay, just let's take a look at it. It says, given that AB and CD bisect each other at M. First of all, what does that mean? What do they mean that AB and CD bisect each other at M? Kevin?
Cut each other in half.
Yeah, cut each other in half. So in other words, if AM is 5 unit, what's MB?
5.
What about DM? Does it have to be 5 also? No. Like if what about if DM is 3 units, then what? MC is?
3.
That's what they mean by they bisect each other. In other words, what is this M in terms of AB? Good. What about this M in terms of CD? Very good. Okay. And if that's true, they say not that the. No, I mean, if this was last night's homework, they would have said, "Oh, show that the two triangles are congruent or something," right? But they don't say that. They say, "Show that AD is parallel to CB, or BC." Are they parallel?
Yeah.
They look like it, but how can we know for sure that they're parallel? It better be they better be parallel, right? Because they're asking us to prove it. Okay, they don't ask us to prove when it's not true. Okay, can't do that. So we know that they're parallel, but how do we know? How do we show? How do we prove it? Nicholas, you see it? How? What would you need to show that AD is parallel to CB?
We need to prove that the triangles are congruent.
Okay, and
And
because just because these two triangles are congruent, does that necessarily say? Yeah, Nicholas.
because you show that it was
Very good. Angle C and angle D. Imagine that AD is a line and CB is a line. What is this DC? Transversal. And so what's angle D and angle C? Those are the? Very good. And if you know that if two lines are cut by a transversal and the alternate interior angles are congruent, then they're parallel. Now, do I have to only use DC? Could I use some other angles? Which one? Raise your hand if you see it. You don't have to just do what DC. You could actually use Amen. Angle A and angle B is as well. Because what kind of angle is AB in terms of AD and CB? Yeah. Now this time, what's your transversal then? AB, right? AB is your transversal, so these are the alternate interior angles again, right? So that's how we're going to show. And you're right. In order to show that A and B are congruent or D and C are congruent, we have to show that the two triangles are congruent. Does that make sense? Do you see what I mean by you're using these congruent triangles to prove what you wanted to prove? Yes, sir.
Can't you just do CP, CP,
What do you mean by that?
CP?
That's part of it.
See the triangles are congruent?
Yeah.
Yeah, CP, CP, so AD.
You're exactly right. In order to, after we have proven that the two triangles are congruent, what is your reason going to be to say that? What is your reason going to be if I want to say D is congruent to C? Corresponding parts of congruent triangles are congruent. You're exactly right. So you know the process that we just did is called plan for proof. That's what we just did. Does that make sense? Okay, so we just plan for this proof. Okay, so let's go ahead and prove this. Question?
Do we write it down?
No. Just I want you to just follow along. But I want you to pay attention. Is that okay? All right, let's go about and so have you noticed in our head we know they're congruent and we know that they're parallel, but actually proving it is a different thing, isn't it? You have to actually, right? It's sort of, you have to actually do it carefully here. Okay. Here we go. First, we're gonna say the given A. So have you noticed that in our head, or we just plan for proof, but right? It's not so easy to actually do a 2-column proof, isn't it? Because you have to do this in logical sequence, right? So that's the part that we're learning, right? In our head, we know why they're parallel, right? So now we're gonna start with this given. What are we gonna say after this given? That AB and CD bisect each other at M. Anybody know what to do? Samantha?
Segment AM is congruent to segment.
That's what a lot of people wanted to do, right? AM congruent to MB, and then what? MD is congruent to MC. Turns out you can't go straight there. Okay? Because just because we know that AB and CD bisect each other at M, right? What would you write down as your reason if you did that, right?
Oh,
You know what I
say
mean?
that M is the bisector.
M is the bisector or M is the midpoint. We have to say that first. Very good, very good. So exactly. So please, this is why we're going over this, okay? A lot of time people just want to say, right? Because in our mind, right, it's really obvious. Of course they're congruent, but we got to do this in, again, logical sequence. So we have to first say that M is the midpoint of A, B, and C, D, okay? Then, and what's the reason for that? Definition of? Definition of midpoint? Have we said anything about definition of? Thank you. Definition of segment bisector or bisector of a segment. Is that okay?
Yes.
Then, afterwards, could we now say AM is congruent to MB and MD is congruent to MC?
No.
Jonathan, why not? Why can't we say from here that AM is congruent to MB and so forth? You said no, right? Why not?
It's because I said yes first.
Oh, do you think it's yes? Oh, why? What would your reason be?
Because you already said that it's
Exactly right. Now that we have said it's midpoint, we could say then these segments are congruent, right? And Jonathan, what's your reason?
definition of midpoint.
Definition of midpoint is correct. Okay. Now, if I want to, next thing I want to say is what? Anybody see what to do next? What do we have to first show in order to show that AD is parallel to CB? Yeah, we have to show that the two triangles are congruent by side angle side, or angle side side side, or angle side angle, right? So which part do we need? We have already shown that AM is congruent to MB and DM is congruent to MC. What's the third part that we need here? Raise your hand if you think you know here. Amy, what do you think? Yeah. You're not so sure? Okay, so last time we learned 3 postulates, right? To show that the two triangles are congruent. Which one of those postulates do you think will work in this case? We have shown that, first of all, AM is congruent to MB, MD is congruent to MC. You think side angle side will work? You're right. Now, how do we then show this included angle, AMD, congruent to BMC? How do you do that? Because we haven't said that yet, right? Are they congruent? Are those two angles congruent? Hold on, Amy, are they congruent? You see this included angle, AMD and then BMC? Are they congruent?
Yeah.
Why?
Because they're vertically.
Exactly right. So you need to say that, okay? Many times people, it's so obvious, right? People have it in their head, they don't state it on the proof, right? In order to use side angle side, how many things do you need to show? 3 parts to be congruent, right? Do we have all those 3 parts? Yeah, we have the 2 sides and the included angle. Okay, then now are we ready to say the 2 triangles are congruent? Yeah, who could tell me? Yes.
Triangle AMD is what? Oh, congruent to B.
Right? Because of? That's right. And do we have the right order?
Yes.
Yes. Okay, so A, the corresponding vertices with A is B, and then D and C, and M is of course same. Yeah, question?
Now you said we have to write it. No, the SAS thing. I thought you said we have to.
Oh, no. You could write it this way, but when you refer to it, you should say side angle side. Don't say it as SAS, which a lot of you are doing. You should say side angle side. But when you write it, it's okay to write it this way. Okay, now what about the 6th step? What do we write next? Okay, Josh?
You have to write down that angle A is angle B
Yeah, not equal to. Angle A is congruent to angle B.
because of corresponding parts.
Exactly right. Now, could I have used D and C?
Yes.
Does it matter?
No.
No. Let's see which one they use. They use A and B. It doesn't matter, okay? And of course, you're right. It's because of corresponding parts of congruent triangles are congruent. By the way, where does that come from? Is that a theorem?
It's a
Where does that come from? This is from the ratio inferior. Where does that come from? Is that a theorem or something that we learned? Because I don't remember proving this. Yeah. It's the definition of what?
Congruent triangle.
That's right. That comes from the definition of congruent triangles, okay? For this one, so I want you to write it out, okay? Don't write down definition of congruent triangle. I want you to write down corresponding parts of congruent triangles. Then, what's the last step? Last step, everyone should know. What's the last step?
Line
Yeah.
is parallel to
Exactly. The last statement you should all know, right? The first. Okay, so then what's the answer for? What's the reason for this one? Nicole? Exactly. If two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Okay, any question? Do you understand? This is the kind of thing, right? Your homework will be something like this. Can you do questions like this?
12 of these?
Yeah, you could do it. Any question? No. Okay, we gotta go a couple more. Okay, couple more. Here we go. Okay, some proofs in this book requires the idea of line perpendicular to a plane. Can somebody, in a minute, don't write this. When I show you the definition, then you write. Can somebody, okay, with your palm and your finger, can you show me, what do you think this means? A line perpendicular to a plane. Show me, we're good. Jason, that's not, okay, yeah, exactly. Does this, right? You guys get that? Now, how would you define it then? How would you define it? Because I'm going to give you a definition for this, like this. You guys all have the right idea. That's right. That's what they mean by line perpendicular to a plane, right? How would you define this? Kevin?
It's a line that intersects a plane.
Good. Line has to intersect the plane. Very good.
Then it creates an infinite number of right angles.
It creates infinite number of right angles. That's exactly what, but they don't say it that way, but you got the right idea. So let's see how, very good, Kevin. So write this down. This is a definition. Write this down. A line and a plane are perpendicular if and only if, so instead of them saying it makes infinitely 90 degrees, it says they intersect and the line is perpendicular to all lines in a plane that passes through the point of intersection. And that's what they're basically saying, isn't that right?
Can we just write his definition?
No. I want you to write this. And here's a picture for it. You see how PO is the line that intersects the plane? And look, every line that passes through O in that plane is going to be perpendicular. Is that right? Yeah. Okay, go ahead, write this down. I'll wait. Okay, so everybody understand what we mean by a line and a plane that are perpendicular? Okay. So I have a question then. Is it possible then for a line to be perpendicular to just one of these lines on this plane X?
Yes.
In other words, let me ask you this. If I have a line perpendicular to the plane, right? Does it automatically give you all lines?
No.
I haven't finished. Okay, so okay, here's my question. Why do they do all this work? Why do they say things? Why can't they just say this way? If, you know, for definition, why don't they say something like line is perpendicular to a plane? The definition will be line has to pass through the plane and it is perpendicular to one of the lines. Why do they say all lines? Because why can't they just say one of the line? Because then doesn't, if it's perpendicular to one of the line, don't you get this picture? No?
No.
Do you see what I'm trying to say?
Yeah.
Why do they have to say that? Why do they have to say all lines in the plane that passes? Why can't they say just one line? Because isn't that the same thing? Don't you get this picture if you just say one line?
No. No, I
Do you understand what I'm asking? Could I replace this all line with just one line?
Oh,
I want you to discuss it with your group. I'll give you time. Go ahead. Why can't I replace that with one line? Go ahead. Everybody think. So the question is, why can't we replace this word all with just one line? Why do we have to have all lines? It's the plane. Anybody? Yeah, you're right. It's because it doesn't work. That's why we do this. But why doesn't it work? Who could give me then the counterexample? Austin?
Because it can be skewed.
What do you mean by that? What do you mean by that?
Because the lines can be skewed. It's a plane.
So the line and the plane has to intersect first of all, right?
So it's
What do you mean? Yeah, Nicole has. Let's listen. Shh, listen. Go ahead.
Isn't it because like a plane has like an infinite number of lines, so it can like intersect the point at any. I mean like yeah. So then there's more.
Anybody? Yes.
Isn't it like if you tilt
Listen.
the
Yes.
toward the side that's like closest to A,
Okay. Listen carefully. You exactly. Say it again. If you tilt PO
like toward the side that's closest to A,
closest to A,
angle POB will still be a right angle.
angle POB will still remain as a right angle.
But angle POA won't.
Angle POE won't.
You can bend it.
Okay.
I get it.
All right. Okay, guys, check. Let me show you. Samantha is exactly right. Watch this, guys. May I show this to you? This is what Samantha is saying. Can I show? Okay, watch this. Imagine this right here is our plane. Okay, this is my plane. Okay, now look. Imagine that this pen is a line on this plane. Are we okay? Oh, I'm sorry. Here, is this better? Okay. So here, imagine that this plane is a line on this plane, and here is my plane that is perpendicular, right up here. Right? Does that make sense? Okay, now, you can see that it's 90 degrees everywhere. You see this red pen? It's 90 degrees everywhere. Let me do it with the pencils so you can see. So here. This pencil, right? Now, what Samantha is saying, okay, this is 90 degrees everywhere, right? And this is what you show me with your palm and your finger, right? This is a plane and a line is perpendicular. Now watch what happens as I tilt this right here like this. As I tilt this, does this angle remain 90 degrees?
Yes.
But what about this angle right here?
No.
This angle is getting,
Smaller.
right? Does that make sense? You understand? That's what you're saying, right? So look, do you understand? Right. Hello? Do you understand? If I do this, do you guys get that? If I do this, this angle is still 90 degrees, right? But this angle right here is not. That's why we need to say what, guys? Yeah, do you see how that all line needs to be there? Does that make sense? Otherwise, you get the different definition. Are you okay with that? Very good. Okay, knowing this down, now this is the definition of, this is sort of an interesting definition. This is definition of what? A line and a plane that are perpendicular. Is that okay?
So you would write definition of a line.
Right, so if you're going to have to use this, so actually let me choose the example next, and you're going to be actually using this, okay? So watch this. Okay, let's go to example. Okay, take a look at this now. Look at example 2. What you're given to you is that PO is perpendicular to plane X, okay? And AO is congruent to BO. That's your given. How do I prove that PA is congruent to PB? First of all, look at the very first thing that's given to you. PO is perpendicular to plane X. Does that sound familiar? This is a line perpendicular to a plane. Okay, so knowing this, is there a way to show that PA is congruent to PB? Let's think about it. Let's think about how you go about proving this. I'll give you time. Go ahead. As a group, I'll give you about a minute or so. Go ahead. Everybody think about it. How would you go about proving this, guys? So who could tell me, I think a lot of you guys got this. Anybody want to tell us how we could go about showing that PA is congruent to PB? Okay, how about Young? What do you think, sir?
You say that POA is congruent, angle POA is congruent to angle POB.
Okay, so is angle POA congruent to angle POB? Yes, sir. Yeah, because how do we know that? Wait. Raise your hand. Shh. Okay. Tony.
Well, by the definition of line and plane that.
Yeah, we said the line that's perpendicular to a plane, isn't that perpendicular everywhere? So there got to be 90 both, right? Okay. So those are congruent. So what? Then next, what do you say? Yeah. How about over here?
PO and PO are.
Sure, PO and PO are congruent because they're sharing the same side. That's obvious. So that's the second part.
Oh, and
And what's the third part we need here?
Oh yeah, you're right.
No, not POR. PO is congruent to PO. We said POA is congruent to POB now. So we have the side and angle congruent. We need the third part. Kevin?
AO is congruent.
AO is congruent to OB because?
Given.
Given. So guess what? The two triangles are? Congruent. Of course, if the two triangles are congruent, John, how do we say that PA is congruent to PB? Because of?
Corresponding parts of corresponding the congruent triangles are congruent.
What?
That's why I don't want you. Okay, say it again.
Corresponding parts of congruent triangles are
Exactly right. Does that make sense? Okay, now, but have you noticed? It's one thing to actually know how, sort of plan it, right? But it's another thing to actually prove, right? Because sometimes we forget like a step and so forth. So let's see whether we could do this, right? So let's go ahead and prove this thing.
So you
So-
have to say
Yeah, you have to
PO
say
is
these things.
congruent to PO.
Hold on, yeah, you do, because if you don't, then you're missing one of the parts to use. If you're gonna use angle side angle, you need to have all those three parts to be congruent. If you're missing one of them, even though it may be really obvious to you, guess what? Your proof isn't correct. Okay? So let's do this. So we did a plan for proof just now, and then here we're gonna start with PO is perpendicular to plane X. That's given. What are we gonna say next? Anybody? Could we say from here, say, oh, because of this, that angle POA is congruent to POB?
Yes. 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 Yes.
The answer is
Yes.
okay. Why do you say so?
So you can use the
What would your reason be if you say from here that angle POA is congruent to POB?
Can I use the definition
Of what?
the line in between?
Okay, could we use the definition? That's a good question. Could we use the definition of line that is perpendicular to plane, right? And say that POA is congruent to POB. Did the definition say anything about angles being congruent?
Yeah.
Look at the definition.
No.
You see, we have to use deductive reasoning. Okay, we have to do this in logical sequence. So in our head, it is obvious, you're right. In our head, we know, of course, it's 90, right? They're all 90, so of course they're congruent. But you have to actually say it in a proof. So what do we have to say then? Naomi, any idea? We can't go straight to POA congruent to POB. But from here, because we know that these, what did the definition say? If the line is perpendicular to the plane, what do we know? Look at your definition. What does it say?
I know. I did.
Hold on. It is perpendicular to all the lines that is in this plane that goes through O, right? So what can you tell me about AO and PO? They're perpendicular. What do you think about OB and PO? Okay, Andrew, so what are we going to say? Fine, here's your chance. What are you going to say as your second chance?
Isn't it PO is perpendicular to AO?
Yes?
PO is perpendicular to PO?
Good, you got it. And what's the reason? Who could help Andrew with the reason for the second part?
Is it the one I said?
Yeah. What is it?
The definition of line and plane.
Exactly. The definition of line perpendicular to a plane is what we use here, right? Do you see why we can't say they're congruent yet? Now, can we say they're congruent now?
Yeah.
Jonathan, yes or no? No, it's not. Okay, we can't say that yet. Okay, Jonathan, what are you gonna say?
You have to say PO is congruent to PO.
No, I know.
Not,
I
no.
know. I know.
Mm-mm. Okay, so what do we need to say next here? How about Brandon? What do you need to say next? After we say PO is perpendicular to OA and PO is perpendicular to OB because of the definition of a line perpendicular to a plane, what do we need to say next? Exactly right. POA and POB are 90 degrees. And what's the reason? Oops. Sorry. What's the reason? Definition of? Yes, we're perfect, right? Now, are we ready to say, Jonathan, that they're congruent?
He's not trusting you.
The answer is yes. Jonathan, why can't we say now that they're congruent? Because they both equal to 90, right? So that's, what's the reason? Shh. What's the reason?
Wait, but don't we have to say when we're talking? Then we say like something about AO is
Yeah, we'll do that in a minute. But since we said that they're perpendicular, we said that they're 90. But what we're trying to establish is we want to say POA is congruent to POB. Okay, right? And that's what we're trying to say. And like I said before, just because they're perpendicular, right? Just because the line and the plane are perpendicular, you can't just go from first line to the fourth statement. You have to say all these things in between. Now, what's the reason, Jonathan, then, that they're congruent here? It's a definition of, because these two are 90, right? So it's because of definition of. If two angles are 90, both of them, are they congruent, Jonathan? Why?
I know it, but then I don't know.
Let me give you a hint. It's because of definition of congruent angles. It's exactly right. Because if the two angles are congruent, what do you know, guys? If the two angles are congruent, what do you know?
They're
They're the same. They're congruent.
If the two angle has the same measure, then they're congruent, right?
Yeah.
Yeah. What's the definition of congruent angles, guys? The angles that have the
same
measure. That's the. Okay, now, Jonathan, this is what you wanted to say. Next, we're gonna say the given, AO congruent to BO, right? Jonathan, are we done then to say that the two triangles are congruent now? Not yet. We need to say the third part. We only have established two parts of the postulates, right? We have the angle congruent, we have one of the sides. What's the next step here? How about Chris? Yeah, PO is congruent to PO. Even though that's obvious, why do we need to say this, class? Yeah, we have to say this. Yeah, we have to show it in the proof. Otherwise, we can't use that postulate. Because postulate requires three parts to be congruent, and you have to show three parts that are congruent. Have we done this? And it's this reflexive property of, again congruence, because we're using congruent. Okay, now, what's our seventh line? Amen? What do we say next? Now we're ready to say that what? We said that already. We got the angle, included angle congruent. We got the two sides congruent now. So we have shown all three parts of this triangle to be congruent. Could we say PA equals to PA at this point?
No.
Not yet. We have to say something first in order to say PA is equal to PB. Exactly right. Now we could say then the two triangles are congruent. Right? Because of? It's not angle side angle, it's side angle side postulate. Right? Because we have the side PO and AO, and then the included angle POA congruent to PO and OB, and then the included angle POB. That's why it's side angle side, not angle side angle. Okay? We've only shown two sides and the included angle, right? Now, what's our last step? Everyone should know the last step now. Okay? How about Yechan? Exactly right. What's your reason? No. If you have corresponding parts, doesn't mean that they're congruent. You have to have something first. Corresponding parts of what?
Oh, the triangle.
Yeah. What kind of triangle?
Congruent triangle.
So say it again. It's got to be corresponding parts of R. Does that make sense, guys?
Yes.
Any question? So, but I don't want you to use that, okay? Because again, as you saw, class, if you use CP, CTC, and all that, right? People don't really know what it means. Right? That's because they don't have much space there. But I don't want you to be using it that way. Okay. Any question? We're not done. Any questions?
No, sir.
Does this make sense? Do you see how, guys? Listen. Do you see how it's really easy to skip some of these steps when you're doing the proofs? Do you now see why we need these steps? Okay. Now, let's summarize what we just did so far. So, can somebody, this is the summary of what we did. And you should write this down. A way to prove two segments or two angle congruent.
We use like 3 lines.
Good. A way to prove two segments or two angles congruent. Okay? Yeah, this is a summary of what we did. Okay, so can somebody read the first one for us? Who haven't read today? Go ahead. Go. Yes, that's our first, okay,
I thought it was
step.
anyway, so it means one.
Right. Okay, so don't worry about it. Okay, so identify two triangles in which two segments or angles are corresponding parts. After you do that, guess what? What are you hoping that this is true? After you do this, can somebody guess what our second step is? This is what we've been doing. After we identify the two triangles in which two segments or angles are corresponding parts, then Tony, what are we hoping to do?
Triangles are congruent.
Exactly. Then we gotta prove then that the two triangles are congruent. Okay. Then we gotta prove that the two triangles are congruent.
Oh, I know.
Then what's the last step? Look at what we're trying to do. A way to prove. So this is one way. Two segments or two angles are congruent. How do we do this? Next. Andrew?
You have to say that the parts.
Yeah, then you say those two parts that you state that the two parts are congruent. Using the reason, Kevin?
The corresponding parts of a congruent triangle are
Exactly. Isn't this what we've been doing so far? Do you guys see that? Okay, so this is a nice summary of what these proofs for. And do you think on your homework tonight this is useful?
Yes.
Okay. Any questions? Any questions? Do you understand? Yes? Okay.